Hey, yeah, let's cover negative exponents, and then in the next video we'll do scientific notation for part one, the exponential exploration. Quotient property. Well, this just going to do a breakdown for you, and then I'll show you there's a couple different ways we can do this, as there is for pretty much everything we do in this class and in math in general. Remember that anything to a power is that number, is that base times itself, in this case, 4 times. So 1, 2, 3, 4 over, we have the base of x to 3. The third power is 1, 2, 3. Now we can go through and just pew, 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 and we're left with an x as an answer, and that's in the numerator. There's another way we can think about this as well. If we have x to the fourth, and here it's not a big deal, but we're going to get into some pretty hairy looking stuff. So let me show you a way we can handle this without writing out all the x's, because what if you have x to the 28th? Ugh, that's exhausting. All right, so if we have x to the fourth over x cubed, here's what we can do. First of all, you need to keep in mind we need to keep our exponents. We need to keep them positive. Exponents need to stay positive. So I need to make sure that whatever I do to these exponents, it stays positive. Now, there is a way I can move this exponent, this base with the exponent, to the top. And here's how I can do that. I can think of it as a couple different ways. All right. The way that I find that works best for students is I need to come along and say, well, I could subtract 3 from the bottom and subtract 3 from the top. Because what I do to the bottom, I have to do to the top. Here's what I'm actually doing here. Here's what I'm actually doing, because you can't just willy-nilly do that. What I can do is multiply by x to the negative 3 over x to the negative 3. This is a fair thing to do. This is completely fair, and this is what I'm doing. 3 minus 3 is 0. Anything to the 0 power becomes 1, gone. In the top, when you're multiplying your bases, it's 4 minus 3. You combine the top with addition. 4 minus 3 is 1. So this leaves me with just an x. X over x to the 0, and x to the 0 is 1. But a lot of people skip this version and just start going minus 3 minus 3. Whatever you feel comfortable with, they're both correct. Okay. The main thing is to keep that exponent as positive. The next one, I'm going to go with this method first, and then I'll do the expansion. So for this method, we've got x to the 6th over x squared. And I find that if I do it with the multiplication piece, this is also going to prepare you for your next class. In your next class, you're going to have to do this a lot. So I want to get this x squared up here, so I can multiply by x to the negative 2 over x to the negative 2. This one goes away. 2 minus 2 is 0. So we've got x to the 0, which is 1. 6 minus 2 is x to the 4th. Let's do the expansion version. So this is x times x times x times x times x times x. There's 6 of them over 2 of them. Pew, pew. 1, 2, 3, 4. Leaves me with x to the 4th. Okay. The next one. Again, I'm going to just put the x's. So x cubed over x and y to the 5th over y squared. All right, here's what I'm doing here. This is a 1. Remember, if it's 0, then that x wouldn't even be there. So instead of rewriting it like this, I'm just going to go minus 1 minus 1. And that's going to leave me with x squared in the top. And then I'm going to subtract 2 from both of these to get the y in the denominator gone. And that leaves me with y cubed. Let's check our work. X, 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 y, 2, 3, 4, 5 over 1x and 2 y's. Pew, pew, pew. Leaves me with x squared and y cubed. All right. However you want to think about it. When the bases match and we are dividing, so when the bases, the x's or the y's match and we are dividing, we should subtract the exponents. All right. The next one is expand and simplify. So again, I want you to think about this in a different way. We can do the expansion piece, and I'll do that here in a minute. We've got, think of this as x to the 1 over y to the 1, because that's what this is, right? We've got a power raised to a power. What do you do in that case? You multiply. So this becomes x to the 1 times 3 over y to the 1 times 3, which is x cubed over y cubed. We learned that in one of our previous videos. Let's do the expand and simplify version. X over y times x over y times x over y, because it's 3 times, is equal to x, 1, 2, 3, over y, 1, 2, 3. All right, expand it. Okay, same concept. So we've got xy over z. So x times y over z times x times y over z times, oh, just two of them. Oh, just two of them. Okay. Is equal to x squared, y squared over z squared. Again, these are all single. So x to the 1, y to the 1, z to the 1. If you're going to take a power to a power, you just multiply them. So x squared, y squared, z squared. Let's do the same thing for this one. So instead of expanding first, I'm going to go through here and take 4. Now rewrite this, 4x squared y cubed over 3z, and I'm going to square it. So that's going to be 4 squared, x to the 2 times 2, because it's a power raised to a power, y to the 3 times 2, power raised to a power, 3 squared, and then z, this is 1 times 2, because this is a power of 1 squared. So this answer is going to be 16, x to the 4th, y to the 6th, over 9z squared. If we do the expansion, I'll come up here and do that. That'd be 4 x, x, y, y, y over 3z. And then we want to do a second one times 4x, x. These are all multiplied, y, y, y over 3z. 4 times 4 is 16. We've got 1, 2, 3, 4 x's. 1, 2, 3, 4, 5, 6 y's. 3 times 3 is 9. And then we have 2 z's. 2 z's. Explain in your own words how to apply an exponent to a fraction containing variables. I'll just give you this one. It's called distribute the exponent to all terms. If you have other methods that you'd like to write, please do that. Whatever makes sense to you. Give me just a moment. Okay, the zero exponent rule. Now, what does that mean? And we've talked about this a lot, or I have. Simplify using our quotient property of exponents from above. And I told you that anytime you have any base raised to a 0, that is 1. So in this case, if we're wanting to, well, first of all, you can see anything divided by itself is 1 as well. But if we're going to treat this with the exponential piece, remember you subtract 3 from the bottom and to move it to the top, and this becomes x to the 0, which is 1. All right. There's another way to do this, which is the expand and cancel. 1, 2, 3 over 1, 2, 3. Pew, 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 is equal to 1. They all reduced. Whenever we raise something other than 0 to the power of 0, so you can't raise 0 to the 0. That is not 1. Okay. We should obtain 0 to the 0 is what? 0. We should obtain a 1. All right, trick question. What is -5 to the 0, and how is it different from parentheses -5 to the 0? And I've discussed this before as well. Remember, if you put this in your calculator without the parentheses, that negative is not going to be a part of that exponent. You have to use parentheses for it to be a part of that exponent. So this negative is separate from the 5 to the 0. So your answer is going to be a negative and then whatever that 5 to the 0 is. 5 to the 0 is 1. So your answer is -1. This one, you're taking the entire number, the entire integer, -5, and raising it to a 0 power. So anything raised to the 0 power is 1, not -1, it's just 1. Excuse me. Negative exponents. Fill in the table, noting the pattern as you go to help with negative exponents. Give answers as fractions, not decimals, when needed. All right. Especially going into, if you're going into college algebra trig, math 1590, you will not use decimals hardly at all. I require you, as most do, to use fractions. All right. 2 to the 4th is the same thing as 2 times 2 times 2 times 2. 4 times 2 is 8 times 2 is 16. You can also do this in your calculator. 2 caret 4 equals, and that's 16. 2 cubed is 2 multiply itself to itself 3 times, and that's 8. 2 squared is 2 times 2, which is 4. And 2 to the 1 is 2. 2 to the 0 is 1. Now, here's something we haven't really talked about. What does a negative exponent look like? And this is the way I want you to think of it. There's a couple different ways we can do this. We've got 2 to the -1. This is the same thing as 1 over 2. Because if we add 1 to the top, you got to think this is over 1. That means we have to also multiply by 2 to the 1 down here. This is 2 to the -1 plus 1. I'll explain it a little different. If I have 2 to the -1 over 2 to the 0. 2 to the 0 is the same thing as 1, right? So I can have 2 to the 0 in my denominator. This might help you see it better. We want to add 1 to both. So this becomes 2 to the 0 over 2 to the 1. 2 to the 0 is 1 over 2. So that is 1/2. Another way to think about it, because my gosh, why wouldn't there be more? If that didn't hit you, and again, this is going to take some practice, is anytime you have a negative exponent for a number or a variable, you can flip the location it is in. If it is in the numerator, as this 2 to the -1 was, you can just put it 1 over 2 to the 1. If that helps you to see it better, let's do this with 2 to the -2. You can take this, remember this is over 1. You can take this and make it 1 over 2 squared. Move the entire base and that negative exponent to the bottom and that, or to the denominator, and that's going to change it from a negative to a positive. It goes the other direction as well. If it was a -2 down here, I could move it to the numerator and make it 2 squared. Okay, so this is 1 over 4. The next one is 2 to the -3. I'm not sure which one of these is going to work best for you, but I'm going to put 1 over 2 cubed, because remember this is over 1, which is 1 over 8. And then the last one is 2 to the -4 over 1. I'm going to just flip where that 2 to the -4 is and make it 1 over 2 to the 4th, which is 1/16. Okay. Simplify using our quotient property from above. Okay, so I'm not going to do the expansion piece. Instead, we want to make sure that we keep our exponents positive. Muy importante. We've got to keep those exponents positive. And so in order to do that, if I brought the 4 up to the top, it would become a -4. I'll show you. Don't write this down. And what happens when I get that? This becomes x to the -1 over 1, which is x to the -1. We don't want negative exponents, so don't do that. Don't do that. Instead, we want to go where it's going to be. And if you did that, we can always put it 1 over x. It's okay. So let's not. Let's see that where is our largest positive exponent? And it's x to the 4. Well, we want to keep it that way. We want to keep it as positive. So I'm going to subtract 3 from both. And it's going to become 1 over x. All right, expand and cancel. All right, 1, 2, 3 over 1, 2, 3, 4. Pew, pew, pew. Leaves us with 1 over x. Remember, when you pew all of these, it doesn't leave you with 0 up here. There's always an assumed 1, always. Because if there was a 0, these wouldn't even be here. All right, simplify using our quotient property from above. Again, let's keep this sucker positive. All right, let's keep it positive. So 2 is smaller than 6. They're both positive. So I need to bring that 2 down here and subtract it. Subtract 2 from both. And we get 1 over x to the 4th. Now we're going to expand and cancel. X times x over x times x times x times x times x times x. This is exhausting. 1, 2. Leaves us with 1 over x to the 4th. That's why we do this. I mean, if you like doing the x's, knock yourselves out. So what should x to the negative 5 be equivalent to? Well, x to the negative 5 is over 1, right? So I just need to move it to the denominator. I can just go 1 over x to the 5th. If it helps you, again, this isn't just a magic, it's happening. There's a lot of math actually happening here. And I've showed it to you, and I'll show it to you again. Just there's a lot. So we can have x to the negative 5th over 1. I can multiply by x to the 5th over x to the 5th, because you can multiply by 1, which is what this is. This becomes x to the negative 5th plus 5 over x to the 5th. This becomes x to the 0 over x to the 5th, which is 1 over x to the 5th. Uh-oh. That's the math behind it. That's only one of the ways that the math is behind it. There are multiple ways I could show you that. To me, that's the easiest. Okay. Let's simplify 1 over 2 to the negative 1. So if I want to think about it this the same way as I just did up here, I would multiply this by 2 to the 1 over 2 to the 1. This becomes 2 over 2 to the negative 1 plus 1, which is 2 to the 0, or 2. You can also think of it as 1 over 2 to the negative 1, adding 1 to both. So you're going to have to do 2 to the 1 up here, which is 2 over 1, which is 2. Or just move it to the top and make it positive. It's the same concept. Let's do that with this one. Let's just move it up here and make it 2 to the positive 4. And it's over 1, which we don't need to write. And that is equal to 16. All right. Following the same idea, what should 1 over x to the negative 2 be equivalent to? Well, it's negative in the denominator. If we move it to the top and to the numerator, it's going to become a positive 2. So x squared. Again, if we want to think about it this way, multiply it by x squared over x squared, and that is x squared over x to the 0, which is x squared. All right. Simplify entirely. Well, first I want to go ahead and put it in the denominator and make it a positive 3. 1 over 5 cubed. Okay. And that is equal to 1 over 5 cubed is 5 times 5 times 5. 25 times 5 is 125. The next one is y to the 8th over y to the 12th. They have the same base. I want to go where the largest positive exponent is, and that is y to the 12th. So I'm going to subtract 8 from both the numerator and the denominator. This becomes 1 over y to the 4th. All right, the next one, ooh, they're both negative. So do we want to go ahead and flip their locations? I think that's a good idea. When we flip their locations, their exponents become positive. So let's bring our 3 up to the numerator. That will become 3 to the 4th. And move our numerator to the denominator. That becomes 4 squared. Now let's go ahead and calculate these. 3 times 3, 9, 81 over 16. The next one is 5x to the negative 2. Well, the first thing we can do is make it positive by putting it 5, put it in the denominator, squared. Now let's deal with the squaring of the denominator. 5 squared is 25. And then x, remember this is 1. A power raised to a power is multiplied. All right, 5x to the negative 2. The 5 is not part of the negative 2 exponent. Only the x is. How do I know that? There's no parentheses. So the 5 is separate. So I'm going to keep my 5 in the numerator where it's positive, and I'm going to move my x to the negative 2 to the denominator and make that exponent positive. Okay. The next one is, I can reduce those. I see a lot of things I can do here. Okay. So I've got 4/8. I want to separate these times x squared over x times y to the 5th over y to the 7th. So this becomes 1/2, reducing it. Both of them are divisible by 4, so I'm dividing both by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Now, my 2 is larger than 1, so I'm going to subtract 1 from both to get rid of my denominator piece, and that puts an x in my numerator. And then here, my 7 is larger than my 5. They're both positive, so I'm going to subtract 5 from both. So my answer is x over 2y squared. Next one. Oh, okay. I'm going to start by putting my 6 and my 5. My x to the 5th is a negative. It's x to the negative 5th. So it needs to go to the denominator to become positive. My y to the 8th is already positive. Now I'm going to come down here and look at these. U to the 4th can stay. It's positive. And v to the negative 3 needs to go up top to become a positive 3. Okay. All right. Oh, same concept. Okay. So we've got, I'm going to just leave the 5 and the 3. Oh, I should separate these. Okay, I'm going to do that. So we've got x to the 3rd, x to the negative 1, y to the negative 2, and y to the 5th. All right, so this is going to stay as 5/3. The 3 up here is already positive. This is negative, so I'm going to add 1 to both to get rid of that denominator one. So that becomes x to the 4th. The 5 in the denominator for the y is already positive, so I'm going to add 2 to both. So it becomes y to the 7th. Okay, before I start canceling these out, I need to go ahead and do my exponents before I divide. If you think of order of operations, exponents come before division. So I have to do my exponents before I can divide. So this becomes x to the 2 times 3 is x to the 6, and x to the 3 times 4 is x to the 12. Now I can go ahead and divide. To do that, I'm going to go where the 12 is because it's already the largest number and positive. I'm going to subtract 6 from both. This becomes 1 over x to the 6. Again, keeping order of operations in play here. If we're going to do our exponents, we can't do anything anyways. So negative 3 cubed over, now this is y to the 1 and z to the 1. So an exponent raised to an exponent, again, you multiply. So it becomes, pardon me, oh gosh. Oh my goodness, y cubed and z cubed. All right, so negative 3 cubed is going to be negative 27 over y cubed, z cubed. All right. Ooh, let's deal with what's happening inside the parentheses before we do the exponent, because back up to order of operations, parentheses before exponent. So let's get that parenthesis looking the way we want before we do that exponent piece. Sorry, y'all. Okay. So my x is already positive. I want my y to be positive. So I'm going to bring it up here to my numerator. My parenthesis doesn't go away, or just my square. 4x and then y squared. Now I'm going to do the exponent piece, which is 4 squared x to 1 times 2, and then y to 2 times 2. 16 x squared y to the 4th. Ooh, this one. So this would be the same thing as taking the xy. Let's go ahead and distribute it. Let's go ahead and distribute it. So this is the same thing as these are both 1. X to the negative 2 over y to the negative 2. I think that's easier to see. So now to make them positive, we just need to flip locations. Y squared over x squared. All right. Got to keep in mind that we need to do what's inside the parentheses before we do our exponent. So I've got an x to the negative 2 that I need to move to the basement, to the denominator. So 4 over x squared y to the 5th, and we're going to raise that to the negative 3. It's negative 3. So that means we're going to, okay, let's do this. So 4 to the negative 3 over x to the 2 times negative 3 is negative 6. 5 times negative 3 is negative 15. Okay, so all of this has to move. I shouldn't have moved it to begin with, but that's okay. All right. Actually, I should have. So I'm going to go ahead and flip these to make them positive before I expand them. So I'm going to move my x to the 6th, y to the 15th over 4 cubed. Now everything is positive. Everything is positive, and I just need to expand my 4. So x to the 6th, y to the 15th over 64. All right. Definitely need to simplify inside of here before I square. So I've got 3 halves. Okay, let's take them one by one. I've got x squared over x to the 5th. I want to bring that 2 to the basement, to the denominator. So I'm going to subtract 2 from both. 5 minus 2 is x cubed. My y, the 6th is positive, the negative 4 is up here. So I need to add 4 to both. So it's going to be y to the 10th. Rosie, stop it. And then z to the negative 8 is in the denominator, and z to the 1 is in the numerator. So I want to bring that negative 8 to the top and make it a positive 8. So 8 plus 1 is z to the 9th. And this is going to be squared. Now I'm going to take each one of these terms, since it's simplified, and square them. 3 squared, z to the 9 times 2, 2 squared, x to the 3 times 2, y to the 10 times 2. So 9 z to the 18th over 4, x to the 6th, y to the 20th. Whew. We're mathing now. Okay, let's deal with what's inside the parentheses first, order of operations, before we even tackle that negative 3. So let's simplify this. 4 over 2, this reduces to 2. So let's get some things happening here. 4 over 2, that reduces this to 2. 4 divided by 2 is 2. My x's, I'm going to bring this 8 to the top to make it a positive, because then it'll be 8 minus 6. 8 minus 6 is x squared. My 4 in the denominator is larger and positive, so I'm going to bring my y squared down. I'm going to subtract 2, so y squared. My z, I'm going to have to bring that negative 3 down to make it a plus 3, and so that's going to be z squared. Okay. Now, let's distribute that negative 3. 2 to the negative 3, x to the 2 times negative 3, over y to the 2 times negative 3, and z to 2 times negative 3. This is going to become, I don't want to deal with this yet. I'm going to hold off on this one because I'm going to have to move this down. Let's go ahead and simplify all of these before I start moving stuff. 2 to the negative 3, x to the negative 6, y to the negative 6, and z to the negative 6. Everything needs to flip. Everything needs to flip, and I knew that because this outer number was negative. So it's going to be y to the 6, x to the 6, nope, z, so sorry, z to the 6, 2 cubed, and x to the 6. There we go. Final answer, y to the 6, z to the 6, 8, x to the 6. Cool. Checking my answers. All right, that's it for this video. Lord have mercy. It's going to take some practice, y'all. Let me know what questions you have. I'm happy to meet with you on Zoom. Nope, don't want to do that.